Anderson, President of LMA Consulting Group and host of Supply Chain Chats. And I'm thrilled to be here today with Eric Rose, who's President and founder of Pinnacle Product Innovation. I'll have him tell you more about it, and we're going to talk about product innovation, new product development, R&D, and how it all relates to what's going on in manufacturing and supply chain circles. So welcome, Eric, and maybe tell us a little bit about your background, and we'll get started.
Thank you. Thank you very much, Lisa, for having me. Sure. I'm a guy who grew up as a machinist in Cleveland, Ohio, ended up going to engineering school, made it out to Los Angeles. Been working for manufacturing companies, small, mid-sized, large, for over 40 years. And then about a dozen years ago, launched my own consulting company.
Very good. Well, that's quite the career, and it's exciting. I know we've known each other for several years as you've focused on new products developments, and I've focused on supply chain, and we've kind of met in the middle. So from that point of view, what would you say is, something that's trending in new product development from your perspective currently?
Sure. I think the integration of design and manufacturing is really coming to a point where if you don't do it, you're going to be in trouble. So the old days of design teams would design something in their ivory tower, throw it over the wall to manufacturing, which is the way it was when I got started in my career. Just doesn't work anymore. It's really doing preliminary design and reviewing it with manufacturing before the final design is ever finished.
So design for manufacturing, does it mean I'll speak I think in terms of common sense type of principles, since I'm not an expert in that particular topic, but is it really setting it up so that the product meets the marketing type of specifications, but it also is something that manufacturing can produce successfully and profitably? Is that what it really means, or would you add to that definition?
Yeah, let me try to give it a little more holistic picture. So when I'm working with clients, let's say they're a small to mid-sized manufacturing company looking to grow their business through new products, I'll talk to them about what I call 3 keys to successful new products. It's marketability. They have to make sure the product is going to be developed in accordance with the market wants. It's technical feasibility, which is really a lot of what we're talking about today. Can the product be designed so that it can be manufactured at a cost low enough where everybody can make money in the channel of distribution? And then lastly, protectability. You don't want anybody to knock off your invention, your product, and so you have to protect it primarily through intellectual property, patents, trademark, trade secrets, etc. But there are other ways as well. When we talk about design for manufacturing specifically, the godfather in the space is a company called Boothroyd Dewhurst. I was trained in their methodology when I worked at Mattel Toys. You can imagine that if you had a factory with workbenches laid out and you had to pick things up off the workbench and assemble them into a product, things like little straight pins would be very difficult. But picking up things like maybe a pencil would be a little easier. Things that might be jumbled, like springs that got intertwined, would be very difficult. But if you're designing these things smart, you would make sure you're getting your supplier to deliver those springs in maybe a little plastic tube so they fall out one at a time and don't get jumbled. These are some of the tenets, the basics of design for manufacturing. And there's many, many others about how to make sure you're not flipping them over back and forth on the line and easy to see things, not a blind assembly and all that kind of good stuff. But there is a whole art and science of design for manufacturing in and of itself.
It makes a lot of sense because as we see with clients, not all of them have designed for manufacturability. So as you just said, several clients where you flip things over or there's extra scrap built into the process. It's not as though that was a plan, but that's that's the outcome. Or it's just not as efficient because you have to, make too many tweaks or whatever. So it does seem like if you can optimize thinking about manufacturability that would make sense up front. And I think probably, Eric, like when I was a vice president of operations for a company, we put together a cross-functional project and we were like designing for manufacturability, but we also, in that case, were designing for freight because it was like a big component of our product cost. So is that like similar in concept, I imagine? Because like in this case, it was like packaging and how much packaging can we fit? How many absorbent products can we fit in a package? And like how do we make that so that the trucks, it'd be ideal for the truckloads and maximizing truckloads? Is that the same concept that we're talking about here for manufacturing?
It's a little different. Design for packaging and distribution should be an element within the product innovation process. So, for example, I worked for a manufacturer that produced durable medical equipment. Think of canes, crutches, walkers, and so forth. We made a chair-like device that stacked. And we did that because we could get 8 in a UPS shippable box
Right.
instead of the old-fashioned metal framed item that didn't stack, and we get 2 in a UPS shippable box. So that's one of the attributes that goes into
Right.
the design
Yeah.
process. But more importantly, when we think of design for manufacturing, it's how fast can you get through the line with the
Right.
least amount of labor, lowest amount of time, balancing the line, all of that when it comes to the design attributes. So whether it's somebody makes the base of the product and screws on, let's say, a circuit board, somebody else screws on a lighting module, somebody else screws on, the battery compartment, and lastly, somebody puts the cover on. All of this is being built, let's say, from the bottom up in an assembly line that's balanced, and everything goes together straight forward, or it might be from the top down if they do it upside down and then finish on the back plate. So there's lots of different ways to do it, but it's just well thought out so that you don't have a ton of labor and not a lot of waste. The whole concept
Right.
of muta, right? No
Yep.
waste, whether that's material waste or labor waste. I'll give you one quick example. Material waste. I worked with a manufacturer outside of Phoenix. They had these little elements that went into essentially like a upholstered item, and it was a trapezoid shape, and they made each trapezoid individual in the tooling with space between each trapezoid item. And I said, wait a minute, if you rotate each and every other trapezoid, they'll nest, and you'll have a
Yep.
common wall in the tooling, and you'll reduce the amount of material by about 25 to 30%. And they go, wow, we never thought of that.
Yeah.
So
Actually,
whether
that happened to some of my clients as well, where nesting can be a big advantage when it comes to materials for sure.
Yeah, so it
So it
could be
sounds to me
packaging
like,
or it could be materials. Yes.
yeah, well, exactly, either. So it sounds like conceptually, like, you're designing the product, you're seeing a trend towards focus on manufacturing ability, which makes sense to me. And, I brought up a related topic, which is design in essence for logistics, which different but same concept. And so, but you're seeing the trend towards manufacturing ability, which makes sense to me because we're seeing significant increases in manufacturing coming to the US as an example. Whether it's, we've been talking about reshoring for many years, but what I'm really seeing is not that companies are stopping production like in China or something and turning it on here, because that's like just doesn't make any sense, because then you've alerted them to the problem. So instead, companies are expanding production in the US, and additional companies are starting up plants and facilities in the US, and then they're going to figure out like how to reallocate their global supply chain. But nevertheless, as they increase their production, bring on, expand facilities or build new facilities, I think that might be a good opportune time to look at making some design tweaks, since they have new operations. Is that what you're saying?
Yes, absolutely. So one example, when I was at Mattel Toys, we were looking at assembling a Winnie the Pooh element for a product, and we were going to do it in China, and it was going to be solvent bonded 2 halves. Well, it turned out that manufacturing decided to reallocate to our factory in Mexico that work,
Mhm.
and they don't do solvent bonding. So
Right.
we ended up having to redesign this Winnie the Pooh with screws. I call them bullet holes in the back of his body, because we had these screw holes, but that's the way ultimately corporate wanted to do it. So if
Right.
we would have known in the first place that it was going to end up in Mexico, we would have designed it that way, either with
Right.
snaps and screws or whatever, but certainly not with solvent bonding.
Yeah, that makes sense. Actually, that reminds me of there's other, I have some clients where they have multiple facilities. They could even be all in the US, but they also could be elsewhere. But nevertheless, as like, for example, the tariffs come up and they're saying, well, you know what? I want to emphasize more of the production in Louisville, the Louisville facility instead of the Canadian facility or the facility in Asia or something to mitigate the cost of the tariffs. Even though they in essence produce the same products, there's nuances like they can't produce it exactly the same. And so is that also what you're talking about? Like take that as an opportunity?
Yeah, it could be plant and equipment is different. It could be labor resources are different. One of the
Yeah.
toys I worked on, we designed it for ease of assembly in one of our Mexican facilities, snapped together essentially.
Yep.
And in the end, manufacturing said no at the time, different time period. We don't want to put that into Mexico. We're going to put it into a contractor in China because we don't know if it's going to live very long. We prefer long-lived items in our own factories.
Mhm.
So by the time we went over to China in that factory, they got rid of all the snap fits, added more labor, and screwed it together because they like to have many, many workers on the line
Right.
and very, very simple injection molding tooling.
Got
Just
it. I see.
totally different plant and equipment requirements.
To your point, like my understanding about like new products and or like even current products, but in essence, so long as they're the same, I don't know, you'll have to tell us, but form, fit, and function, I
Function.
guess,
Right.
then you're okay producing them slightly differently from a customer standpoint. But to your point, that doesn't necessarily mean they're the same manufacturability from that
Right.
standpoint.
Right.
That's
So
somewhat what you're talking about.
any product has to meet those end functional requirements. So for an infant preschool toy at Mattel, it was, 5 feet drop, a 5 foot drop 12 times, and it couldn't fail in any way that could cause injury to a child. So it doesn't matter whether it's made in China or made in Mexico or made in the USA. It has to have that function, that product
Mhm.
quality, has to look the same, work the same, and even if the guts are different, those, as you said, fit, form, function requirements are still there.
Interesting. And so do you, from an engineering standpoint, then, do you think about or collaborate with like equipment suppliers, or how does it, what's the best way to go about that?
I'm not usually the equipment supplier, but usually the equipment is deployed in a factory. So, for example, I do a lot of work with injection molding. The
Mhm.
machines are certain size, let's say 500 ton, which means it's got 500 clamp tonnage capability. So the mold can be a certain size, but it
Right,
might open at a certain distance or have an ejection stroke of a certain dimension. All of that information has to be known before a product is designed so that
right,
we know it can go into that factory without having to buy new, let's say, molding equipment. We don't want to do that.
right. So I guess you should take into account the specifications of, like you said, the equipment. Um, Maybe. I mean, would you take into account the skills of the people? I mean, that seems.
There are some
I don't
times where
know.
we
I'm
will.
unsure.
Yeah, so one of the projects I worked on for an industrial products company, a full face respirator, they were an expert at applying non-scratch coating onto polycarbonate lenses.
Okay.
So we learned from them the requirements they had for the product to be run through that coating line.
Right.
How are you going to hold it? What way is the orientation? If there ends up being a drip, where would that drip be hidden in the assembly or an area that's non-coated? So those are the kind of questions we would ask to ensure that we're designing the part in accordance with the manufacturing processes.
Well, I mean, it certainly is important because when it comes to planning and like sales, inventory operations planning, we're counting on, typically speaking, we're going to look at ramp up curves for a new product launch, and that could really get blown out of the water in a bad way if the product is not as nearly as easy to manufacture as it seems based on the design. So I've seen most clients do not succeed in achieving their initial projections of ramp up plans. So, but obviously the better job you do taking manufacturing into account, I'm assuming the better you're gonna perform.
I would say manufacturing and supply chain because I worked on one project, again, a Mattel project manufactured in Mexico, and we were doing a pilot run before the full production. And I'm there in Mexico trying to make sure all the parts are in. And sure enough, one drive belt, standard item off the shelf, had not arrived.
Well,
And we
that is
there,
true.
and at Mattel we used to say Christmas doesn't move, right? You can't be
Right.
late to Christmas. Sorry, Walmart, we'll be delivering our goods 2 weeks after Christmas. That's not going to happen.
It's totally true. I mean, you're, as I am always saying, you're only as strong as the weakest link in your supply chain. So in this case, to your point, certainly could be a part to a machine, or even, a supplier or a skilled resource of some sort.
Right.
Actually in injection molding and there's like certainly skilled positions. I forgot what they call them now. But anyway, in essence, where the people who design the tooling, I mean, there's like a lot of like potential bottlenecks to be sure.
Absolutely. Usually molds never go as planned. We used to say, it's an 8 week mold build time and an 8 to 12 week debug time after you run the first samples because it's never right. I think in over 40 years of doing this, one part came out exactly as planned the first time.
That's pretty funny, but true.
Yeah.
And you brought up an interesting point. 'Cause a lot of these things I don't think about until we're having this kind of a conversation. But working with a client that utilizes nesting as well, it's not molding, but nevertheless, the nesting concept can be a significant advantage to your point, because in this case, like they perform much better than their competition. And then they were bringing in, I guess you could say, somebody, a partner, a supply chain partner, but because they didn't have the same nesting like thought process, or really they hadn't built in the manufacturing ability into their designs, like it created a significant amount more of, well, either one of two things: scrap, or it was like took a lot longer because you had to, well, both really, because if you didn't nest it right, you had more scrap, and it was slower because you had to, it took more time to get to what you needed. So I think you're absolutely right. I mean, it can make a significant impact on your ability to scale production. Is that what you
Yes.
see as well?
Another example there, medical device, a dental device had to get loaded into a vacuum formed plastic tray so that it could move through the production line, ultimately into packaging. But the engineer, developer working on the tray didn't understand all the downstream manufacturing requirements. He was kind of in his own little space. He didn't realize that when those trays were originally designed, they weren't designed to be nested. And there
Right.
needed to be nesting features so they could be stacked up in the warehouse and removed one at a time and then moved down the line. And so
So,
when they first opened the box of vacuum formed trays, they were helter skelter and it was very
yeah.
difficult to manage and they didn't sit flat on the conveyor line and so forth.
It's actually, there's a lot you have to think about in new product development, because when I was in my the main when I was the vice president of operations and we were doing a major R&D project, I was more of a like cross-functional project leader, if you will. And since I'm not an engineer by trade, but to your point, a lot of these topics you're talking about came up because you really do need to think about how, like, how do you optimize between the performance of the product, the ability to manufacture the product, what this means in terms of material, like material usage, which could
Yes.
be different from scrap,
Yes.
right? And then we also worked with suppliers in our case, as well as some equipment suppliers, to like try to bring it all together. So it sounds like that's what you're talking about. It reminds a blast from the past, I guess.
And it's layered all with a little dash of packaging and distribution logistics.
Well, in our case, for sure, because we had it was we had bulky, fluffy product, but it was not heavy. So it was like, how do you do all that? And then actually what you brought up that reminded me of this situation is you even have to consider like customer specs. I mean, obviously it has to meet basics, but in our case, we were putting it into, the customers wanted to put it into a cabinet. So like as much as you could like try to condense these products so that you would have less packaging,
Mm.
it didn't matter at all if it didn't fit in the cabinet. So you have to be, to your point, you have to understand the end-to-end supply chain. I would
Yes,
think that that's probably one of the keys to success here. Is that true?
absolutely. And whether it's in a home in a cabinet, or a lot of times we face issues of, let's say, a retail shelf
For sure. If it
and
doesn't fit on
Target,
the shelf, what are you going to
right, Target had
do?
very specific requirements for, let's say, when I was in the puzzles and games group. Those boxes were those size with that much of a facing, depth, height. The gondola shelves were so tall. All of that was
Yeah,
mission critical.
really good point. I mean, that kind of reminds me of like merchandising in essence, they
Yes.
sometimes call it, right? Because when I, also a blast from the past is I worked at Coca-Cola and we had to, that was the idea, is like where is it going to fit and how does it fit on the shelf, to your point, and it definitely
Yes.
matters.
Right. They use the term planogram. So it's a
Yeah.
map of what products are going to be on the shelf, how many deep, how tall is it, the facing, all of that.
Oh yeah, there's definitely like a lot to take into account. So I guess what you're saying is as you're, moving production, increasing production, wherever it is, I mean, you should be thinking about at least making some smart choices as far as product redesign or some product design tweaks anyway. Like, are you seeing more tweaks as well from an automation and like, I don't know, advanced technologies, I guess, point of view? Because I don't know if there's something to do with robots, maybe, because like if you're putting it on the production line, there's automated equipment, it's got tight tolerances. I mean, I'm not sure, but I assume. Can you do something where you design a product that's going to be better manufactured in in today's environment where it's like quite a bit of automation versus China, which to your point, I mean, China's changed a lot over the years, but generally speaking, like you said, they wanted to keep their people working, which is different from here. We don't have the people,
Or they're too expensive.
or they're too
Hmm.
expensive. Yeah, or both.
Sure. So there are some similarities. For example, during assembly of products, typically there are features in the product that facilitate manufacturing, such as a lead-in between two parts
Mhm.
and then the snap. So it's very prescribed in the design. And whether that's assembled with a robot or assembled with a human, um, that either way, you're going to need that kind of design.
Right, that makes sense,
Robots will be
actually.
more precise generally.
Right, right. That's true. Actually, I mean, you're right. I mean, it makes sense. And it's somewhat true with like even when I'm thinking about this food manufacturing client, they made them like um bars, like breakfast bars or something. And I mean, it's a good example because like it reminded me of that I Love Lucy episode. Because if with automation, things just start flying off the line and, or whatever. I mean, it wasn't quite that literal, but sort of like, in terms of waste would be flying off the line. If things weren't,
Chocolate.
you have to, I mean, it's not all because of the product design, obviously. Some of these are operational issues and other things, but it seems like you could probably just do the best you can to optimize the design to at least eliminate that or mitigate that particular problem.
Sure, with robots, there may be opportunities to be a little more efficient. You can add certain defined places to pick up an object that might be not necessary for a human. There might be vision spots where they need to have a hole in a particular place, which is might maybe the master datum. Everything goes together based off of that location, different attributes in the product. But either way, the objective here is to understand how the product will be assembled and incorporate those necessary attributes, human, robot, otherwise, into the product.
That makes a lot of sense. It really does. Are there any like best practices? And these might be more generic. I don't know if that's the right word, but to product development, like one thing that I think of from a planning standpoint, because that's one of the areas I focus on, is there are times, especially with companies with quite a bit of R&D happening, is you want to have like set aside time on a particular line or even a whole line. It depends on what you're doing and whatever, so that you can like test out these theories. And then I suppose as you test out the theories in a pilot type of environment, I would assume you would incorporate feedback, but I know I'm not, you're the expert here. So is that like, are there some like best practices that way that would help?
Yes, the best companies do that. American Hospital Supply, first company I worked for out of college, now bought by Baxter, they had a separate factory. It was a pilot factory, and it allowed them to be removed from what I call the day-to-day vortex of production, shipping, and so forth. So once the product came out of design, engineering, prototyping, and went into tooling, after tooling and the first parts were coming off tooling, they started to assemble them in the pilot factory. They would continue to make changes through the piloting process. Then exiting the pilot process, the design was frozen that had optimized manufacturing, and the tooling was frozen, and they could pack up the tooling and move it to a different factory. So it was moving out of the pilot factory into a production factory. So that's a bit of a luxury.
It is, but you did remind me of a client that, like in biotech, they made like proteins, and they actually did have an R&D facility, and just reminded me, but that's in essence what they were doing. To your point, it's a luxury. They're the only client that I've had that had an entire factory for that purpose. But many clients have had like dedicated line time on their lines or something like that we plan for. It seems like that would be important, especially to ensure success with these types of projects.
And I look at it the other way, which is manufacturing companies that have production lines loaded at 90+% capacity 24/7 and don't have any time for R&D.
Right.
And if R&D doesn't have their own capability, then to break into a production line is not going to happen.
Well, I mean, you're right, because especially today it depends, of course, what type of market we're talking about, industry, but there's a lot of volume coming back to the US in terms of manufacturing. It's not all from China. Some of it's from all over the place, because there's like a lot of pharmaceuticals, medical products, different types of things. So if you're really maxed out on capacity, which a lot of companies would consider a good thing because they're trying to maximize the use of their equipment. But to your point, I think it's important. So I'll emphasize and support what you're saying here. But I think it's important that we set aside enough time, whatever that means, but enough time to make sure that you're successful. It's sort of like, traditional plan, do, check, act type of model, right? You have to like start with the plan. You have to start somewhere. that make
Yes.
sense? Yeah.
And it should
Yeah,
all bubble
interesting.
up to a strategic plan. If the
Yes.
strategy of the corporation is to grow, let's say, revenue from new products by 20% continuous for the next 3 years, what are we doing in design, resources, production piloting,
Yeah.
production tooling, plant capacity, warehouse space for all of that?
Yeah, absolutely. And it really should roll up to everything and then be a part of your SIOP process. So sales inventory operations planning so that you can make sure that you're setting aside and planning it through. What's your sales plan in terms of ramp up strategies? What's your, what does this mean in terms of capacity? So I completely agree. And I think it's something that you could easily overlook. So I think it's an important thing to remember.
I'll
Say,
add one more thought here. On a project I worked on, the company wanted to grow, wasn't sure how to grow. I helped them to get into a new and adjacent market with a technology they didn't have, but a strategic partner had. And the product was perfect for their distribution channel and the sales force they already had. That allowed them to not have to increase floor space, not have to buy new capital equipment. Sure, they were paying the margins of a contractor, but they were also testing the water as to whether this new product category was going to be successful or not. And when the product outstripped sales by 50% the first year, they were happy and they made sure they had enough room in the warehouse.
that's a really good point. When I was in that role of the VP of operations, we had a product line like that, which was like which we thought might be the future. And so we did just what you just said. We took on a strategic alliance kind of a partner, so stronger relationship than just a vendor, if you will, to get the product line started, which allowed you to scale more quickly. And then they built it into the capabilities over time, right? So that, then they didn't need, the strategic partner long term necessarily. But I think more and more I'm starting to see strategic partnerships is the only way to go, because how do you build to scale when you're trying to move the kind of volume that's happening today? Like, for example, China's #1 in manufacturing in the world, and you can't bring over that kind of volume. And like, if you go from 100% to 200% in the US, it's like peanuts in many cases. So you have to go from 100% or 100 to like 1,000 or 10,000. So
Sure.
that's a whole different matter. So I think you're absolutely right. I'm glad you brought that up. You have to consider those types of, options.
With the smaller businesses that I work with, I generally recommend they use domestic manufacturing, theirs or contract. If they really scale up quickly and large and are worried about margins because there might be competition and the profits are getting squeezed, then we can take it over to Asia. But don't start new products in Asia because they're generally, from my experience, not great at starting up new products.
Well, I would totally agree with you. Like for sure, R&D should be focused where you have better control and you understand
Yes.
like you can do it quickly, timely, and even like what I'm seeing a trend towards more of a regional supply chain anyway. So you may even look towards Latin America. It's going to be a interesting transition though, because the expertise, where is it today versus where is it going to be in the future, and how do you make that path? But if nothing else, R&D is going to be critical if you want to ensure that you can continue to grow the business successfully and stay up with changing customer conditions. So yeah, I
I think
agree.
you and I have talked about how to protect your intellectual property as you grow through new product innovation. And I know many of my clients will source different sub-assemblies from different locales and do final assembly here in the US. So no one subcontractor in China or elsewhere has the keys to the cabinet. They can't just
That's
knock
another
off the
really good
entire
point.
thing as easy.
Another really good point, Eric. I mean, I completely concur with that and recommend it because, again, you can't scale fast enough on your own necessarily, unless you're a relatively large company, generally speaking. But you want to do something innovative that's quick, that you can then, take control over time. So I completely agree with that. And you don't want to give away the keys to the kingdom, because believe me, if you put it out there, they're gonna IP laws or not, especially if we're talking about China, they're going to copy it.
Yes.
It's gonna happen. So
Yes.
anyway, time has been flying by. Do you have any last thoughts that we should that note for folks? But this has been really valuable.
I would just say, don't be afraid to innovate. Just do it in a smart way. Smart in terms of first ensuring the most valuable features in the product are the ones where you're focusing on. And that if you have to give some features up in the product, either because they're too expensive or you can't make them manufacturing wise in your factory, whatever, just keep in mind whoever those stakeholders are and design, develop, and manufacture those products with a very clear pulse on what your customers want.
I think that's a great way to wrap it up, and I completely concur. I think there'll be more opportunities than ever before in history for companies that are innovating and thinking about future customer requirements and are willing to take on some risk, but do it in a smart way. So I completely concur that, I think that'll lead to success. So thank you very much, Eric, for
My pleasure.
joining us today and sharing your expertise with our audience. So thank you very much.
My pleasure.